All right, let's dive right in. Today, we're laying out the complete blueprint for deploying your very own AI agent infrastructure right in the cloud. We're talking about getting away from those unpredictable API bills and any worries you might have about privacy. This is all about giving you total control, predictable costs, and some seriously high performance. Let's get to it.
So if you're building with AI agents, you've probably felt this pain. You have this amazing idea, it starts to take off, it starts to scale, and so do the API bills. They just keep climbing. And maybe more importantly, you start asking yourself, am I really comfortable sending all this potentially sensitive user data to a third party? These are the real-world challenges that are making developers look for a better solution.
And that better way, it has a name. It's called running a local LLM in the cloud. And honestly, it's the best of both worlds. You get all the raw power and, crucially, the privacy of running a model on your own terms. But you also get the reliability and the massive scale that comes with a real cloud provider. You are in the driver's seat. You control the model, you control the data, and you control the costs.
Okay, here's our game plan. First, we're going to talk about why you'd even want to move beyond APIs in the first place. Then we'll get into the nitty-gritty how, picking the right architecture, matching your models to the right machines, and laying out the actual connection blueprint. And we'll wrap it all up with some pro-level hardware optimization and a final checklist so you can build your setup with total confidence.
So let's start with that fundamental question, right? Why go through all this trouble when, let's be honest, APIs are just so easy to use? Well, as you're about to see, the reasons are actually incredibly compelling. The benefits here are just huge. First and foremost, total data privacy. Your information never ever leaves your control. Period. Then, costs become predictable. You're paying a fixed price for a server, not a tax for every single thought your agent has. Plus, you get the freedom to use any model you want. You're not locked into a single vendor's ecosystem. And on top of all that, you can often get much lower latency by putting your server geographically closer to your users.
All right, so you're on board. The first big decision in our blueprint is picking the right cloud architecture. And this is a big one, because this choice really defines how your agent is going to scale and operate down the line.
So let's break down the three main flavors you can choose from. First up, you have the serverless pattern. Think of this as separating your agent's brain, the logic, from its muscle, the LLM. The logic runs on a lightweight, super scalable platform, while the heavy lifting model runs on its own dedicated GPU server. Keeps things clean. Second, you've got the containerized cluster. This is like putting your entire operation into a self-contained box using tools like Docker and Kubernetes. This gives you maximum control, and it's perfect for really complex setups. And third, there's the managed AI platform. This is where you let one of the big cloud providers handle a lot of the messy setup and maintenance for you, letting you just focus on your agent's core logic.
Now, where do you actually run all this? This table kind of breaks down the provider landscape. If you want the absolute lowest cost per GPU hour, say for development or experimenting, you're going to look at specialized providers like RunPod or Lambda Labs. For big enterprise needs, where security and deep integration are key, you'll probably go with the hyperscalers, AWS, Azure, or GCP. And for that serverless pattern we just talked about, there are specific platforms designed just for that kind of decoupled architecture.
Okay, now for what is arguably the most critical part of the whole technical plan, matching your model to the right machine. This is so important because the model you choose literally dictates the hardware you're going to need.
And here is the one fundamental equation you have to remember. The size of the model, which we measure in parameters, directly determines how much GPU, video memory, or VRAM you're going to need. It's a straight line. A 7 billion parameter model and a 70 billion parameter model are completely different animals, and their VRAM needs are worlds apart. It's simple. More parameters means you need more VRAM.
So let's start at the entry level. For these smaller, super efficient models in that 7 to 8 billion parameter range, you can actually get started with a GPU that has just 8 to 16 gigabytes of VRAM. This is a fantastic, really budget-friendly way to get in the game with agents that are surprisingly capable.
Now, stepping up to the mid-range, this is where you're looking at 24 to 48 gigs of VRAM. And honestly, this is the sweet spot for a lot of production-grade agents out there. It gives you enough horsepower to run those more advanced models. Think 13 to 32 billion parameters. And that's where you really start to unlock some seriously impressive reasoning abilities.
And then, you have the heavy hitters. We're talking about the flagship 70 billion parameter plus models. For these, you have to bring out the big guns. That means 80 gigabytes of VRAM, or even more, on cards like the NVIDIA A100. This is also absolutely essential if your agent is doing heavy RAG, retrieval augmented generation, which involves feeding the model lots of external documents. That process is very memory intensive. But wait, here's a little magic trick. Before you go and spend a fortune, you need to know about a technique called 4-bit quantization. It can shrink a model's memory footprint by up to 70%. I'm not kidding. This means a massive 70 billion parameter model that would normally need over 140 gigs of VRAM can suddenly fit comfortably in just 43 gigs. This one technique completely changes the whole cost-performance equation.
Okay, so we've matched our model to a machine. Now for the fun part. Let's get into the practical, hands-on steps. This is the blueprint for actually connecting all the pieces together.
And the good news is, the pattern here is simple and it's repeatable. First, you provision your cloud instance. Second, you install the software that's going to serve your model. Third, you secure the endpoint. And finally, you configure your agent to talk to it. It's a clean, 4-step process. Provision, secure, configure, integrate.
So let's break down that server setup. Step 1, you provision your GPU virtual machine in whatever cloud you've chosen. Step 2, you install the necessary NVIDIA drivers and the CUDA toolkit. That's a must. Step 3, you run an LLM serving stack, something like Llama or VLLM, which basically turns your model into an API. And finally, and this is critical, you secure that endpoint so that only your agent can actually access it. Now, connecting your agent, in this case we're looking at OpenClaw, is surprisingly simple. You just go into the settings for model providers, you add a new one, and then you point its base URL to the private IP address of the server you just set up. A lot of these serving tools even mimic the OpenAI API format, so configuration is just a breeze. You're basically just telling your agent, hey, stop calling OpenAI, from now on, call my private server instead.
Okay, the connection is made. Now, let's zoom in a little bit on the hardware itself and talk about how to squeeze every last drop of performance out of your new setup. For a truly professional setup, you got to look beyond just the GPU. As you can see here, a powerful CPU is absolutely critical for handling all the other things an agent does, like using tools or retrieving data. You'll want plenty of system RAM to cache your vector database for those fast RAG lookups. And you can't skimp on fast NVMe storage and a speedy network connection. Otherwise, you're just creating bottlenecks somewhere else in the system.
And for those of you who are ready to level up, here are some pro-level optimizations. We already covered quantization, that's a huge one. Then there's batching, which is where you group incoming requests together to get higher throughput from your GPU. Things like context summarization and flash attention are super clever techniques to handle long conversations more efficiently. And for serious production workloads, you should definitely look into auto-scaling with Kubernetes. That lets you scale your GPU power up or down to handle traffic spikes without paying for hardware you're not using. Okay, we have covered a ton of technical ground, but making the final decision isn't just about the hardware specs. It's time to look at the complete picture with our final checklist. You see, a truly successful deployment has to balance technology with real business needs. On the business side, you've got to think about things like cost predictability, data compliance with rules like GDPR or HIPAA, and what kind of uptime guarantees you need. And on the technical side, you need solid plans for how you're going to scale, how you'll monitor everything, and of course, your security and backup strategy. The perfect solution lives right at the intersection of these two worlds. So there you have it. That's the entire blueprint. We've walked through the why, the what, and the how. You now have the architectural patterns, the hardware guidelines, and the step-by-step process to build a powerful, private, and cost-effective AI agent in the cloud. The only question left is, what are you going to build with it?